heat pump working as a reversed Carnot cycle has a COP of 5. If it is made to work as refrigerator, 1 kilowatt of work input, the refrigerating effect will be. Here the options are 1 kilowatts, 2 kilowatts, 4 kilowatts and 5 kilowatts. Coming to the solution, here heat pump working as reversed Carnot cycle has a COP of 5. But we know that the COP of the heat pump is equal to COP of the refrigerator plus 1. So from this equation the COP of the refrigerator is equal to COP of the heat pump minus 1, that is 5 minus 1, which is equal to 4. So here the COP of the refrigerator for the Carnot cycle is 4. But we know that the COP of the refrigerator is equal to refrigerating effect by work input. So here for 1 kilowatt of work input, we'll have to find out the refrigerating effect. That is, refrigerating effect is equal COP of the refrigerating work input, that is 4 into 1, which is equal to 4 kilowatts. So here the right answer is 4 kilowatts, and in the option the correct option is C. C is the right answer. In an orthogonal cutting process, rake angle of the tool is 20 degrees and friction angle is 25.5 degrees. Find the shear angle. According to the merchant's theory, the relation between the shear angle, friction angle and the rake angle is given by 2 pi plus beta minus alpha is equal to constant. But here nothing specified about the constant, so that it should be considered for the minimum work, that is equal to 90 degrees. And alpha is rake angle, beta is friction angle and pi is shear angle. So from this equation, the 2 pi plus the friction angle is 25.5 minus 20, which is equal to 90, and pi is equal to 2 pi is equal to 90 minus 20, that is 95.5, and pi is equal to, sorry, it is 84.5, and here pi is equal to 42.5 degrees, 42.25 degrees. So here the right answer is 42.25. Correct option is 42.5, that is B. Here it is 42.25, sorry. So in the options the correct option is B. Manufacturing is suitable for. Here the options are single product in large volumes, one-off production of several varieties, products with similar features, and made in batches, large varieties of products in large volumes. Here the right option is C, that is products with similar features made in batches. Arc flow occurs predominantly in, here the options are AC arc welding, DC arc welding, gas welding and gas cutting. So generally arc flow occurs in DC arc welding rather than AC arc welding. So when in DC arc welding of magnetic metals like iron and nickel, arc flow occurs, but in case of AC it is considerably lower than when DC is used. Mean and variance of consumption of an item are 116. The area under the normal curve for Z is equal to is 0.95. The reorder point for 95% service level will be. Here the options are 108, 100, 92 and none of these. So coming to the solution, the reorder point is given by mu plus alpha z, where mu is equal to mean and alpha is equal to root of variance. So here variance is given by 16 and is equal to 4, and for the 95% level z is equal to 2, so that the reorder point is equal to 100 plus 2 into 4 and is equal to 108. So the right answer is 108, and in the option the correct option is A. A is the right answer. An item is produced at the rate of 50 items per day. The demand occurs at the rate of 25 items per day. If the setup cost is 100 rupees per setup and holding cost is 0.01 rupee per unit of items per day, find the economic losses for overseen. Assume the shortages are not permitted. Here P is equal 50 items per day, let us say, and P is the demand. Demand occurs at the rate of 50. P is the items produced, that is at the rate of 50 items per day, and demand occurs at the rate of 25 items per day, that is D is equal to 25. If the setup cost is 100 rupees per setup, that is, let us say CO is equal 100 rupees and holding cost is 0.01 rupee, that is generally represented as CU lambda, that is equal to 0.01. So here the economic lot size is equal to root of 2 C naught S into by Cu lambda into 1 minus d by p. So which is equal to root of 2 into 100 into 25 by 0.01 into 1 minus 25 by 50, which is equal to 1000 units. So in the option the right answer is A. A is the right answer. Technique, flame is directed towards the weld portion is. Here there are two techniques. One is forward welding technique and another one is backward welding technique. In forward welding technique, the flame is directed away from the welded portion or welded joint. But in case of backward welding technique, flame is directed towards the welded portion or welded joint. So here the options are in this option the correct option is B. B is the right answer.
In this problem, we have to find the value of the integral 1 to 2 dx by root over x minus 1 into 2 minus x. Now, in order to find the integration, let us go for certain substitution. So, what we do is, let us take x as 2 sine square theta plus cos square theta. So, the value of dx will be 4 sine theta into cos theta plus 2 into cos theta into minus sine theta, which can be written as 2 sine theta cos theta d theta. Now, x minus 1 will be 2 sine square theta plus cos square theta minus 1, which is equals to cos square theta minus 1 is nothing but minus of 1 minus cos square theta, which is minus sine square theta. So 2 sine square theta minus sine square theta is sine square theta. Similarly, we'll find the value of 2 minus x, which is 2 minus 2 sine square theta minus cos square theta. Now, if I take 2 common, it will be 1 minus sine square theta, which will be 2 cos square theta minus cos square theta. Again, the result will be cos square theta. And the upper limit, if I substitute x as 2, here, then the value of theta will be pi by 2. And if I substitute x as 1, then the value of theta will be 0. So the lower limit will be changed to 0 and the upper limit will be pi by 2. And dx is nothing but 2 sine theta cos theta d theta by root over x minus 1 is nothing but sine square theta. Similarly, 2 minus x is cos square theta. This can be written as 0 to pi by 2, 2 sine theta cos theta by sine theta cos theta d theta, which is nothing but 2, 0 to pi by 2 d theta, which is nothing but 2 into pi by 2. So the answer is pi, that is option B. So in this problem, it is given that a balloon which is always remains spherical is being inflated so that its volume increase at the rate of 50 cc per second. Now we have to find the increase in the radius when the radius is 15 centimeters. So the balloon is always spherical, so the volume of a sphere is nothing but 4 by 3 pi r cube. And also he said that it is inflated at the rate of 50 cc per second. So dv by dt is nothing but 50 cc per second. And we have to find the change in radius, that is dr by dt, when r is equals to 15. Now consider equation 1 and differentiate it. If I differentiate with respect to t, it is dv by dt is equals to 4 by 3 pi into 3 into r square dr by dt. Now dr by dt can be written as 1 by 4 pi r square into dv by dt, and let us substitute the values. 1 by 4 into 22 by 7 and the value of r is 15. So 15 square into 50. If we simplify, then the value will be 0.0176 centimeters per second, which is option A. Now in this problem, we have to find which of the following is incorrect statement. Now let us look into statement 1, that is option A. A minus 2, B minus 1, 3A minus B, A is given as B minus 2, 2, 6B, and is saying that A will be 0. Now let us equate the fourth terms. So that is nothing but A is equals to B, and also 3A minus B is equals to 6. 3A minus B is equals to 6. If I substitute A as B, so it will be 2B is equals to 6, then B is equals to 3. And if B is 3, A is also 3. That means this statement is not correct. So option A is true.